His high score in one-day cricket. One more. This time a longer one. Probably the longest.
Amazing! That was a huge six, right? 107 meters into the stands. But how was the distance of the six calculated? What do you think? Was it simply a guess? Let's look at another example. When a jet shoots down targets that are very far away, how does it locate the targets with such precision? Again, is it just good guessing? Apart from these two examples, there are many similar situations which seem really complex to solve. But it is important to understand that solving complex problems like these don't involve guesswork or luck. They require the application of various concepts of mathematics and physics. And today, we are going to learn one of these concepts called quadratic equations. So, what is a quadratic equation? Let's try to understand this with a puzzle. We have two friends, Jay and Viru. Jay is 5 years younger than Viru. And we also know that the product of their ages is 50. Can you figure out their ages? Let's express this information mathematically and see if we can figure it out. We don't know Jay's age, so let's say that it is X years. Now we know that Jay is 5 years younger than Viru. So Viru is 5 years older than Jay, right? That means Viru's age would be X plus 5 years. We also know that the product of their ages is 50. So X multiplied by X plus 5 would be 50. If we simplify this equation, we get X squared plus 5X is equal to 50. So just by solving this equation, we can find the value of X and we would know the ages of Jay and Viru. But here's the question. How would you solve this equation? It looks difficult, right? We'll learn how to solve such equations later. But for now, take a look at this equation. Does the left-hand side look familiar? You might have studied similar expressions before. Notice that the highest degree of this expression is 2. You might remember from earlier lessons that expressions of this kind are called quadratic polynomials. So expressions like x squared plus 2x, 2x squared plus 5x plus 1 are examples of quadratic polynomials. So what we got from the puzzle, x squared plus 5x is equal to 50, is an equation whose left-hand side is a quadratic polynomial. And when a quadratic polynomial is equated with something, we call it a quadratic equation. In other words, we can say that equations with one variable and degree 2 are called quadratic equations. So all these equations are examples of quadratic equations since they have just one variable and the degree is 2. Now that we know how to define a quadratic equation, let us try and understand how to represent such equations. So how do we do that? In maths, we have something we call a standard form. For example, remember the standard form of quadratic polynomials from our previous lessons? Let us now see what the standard form of a quadratic equation looks like. The standard form of a quadratic equation is given by ax squared plus bx plus c is equal to 0, where a, b and c are any real numbers. But where a is not 0. But why can't a be 0? Because if a is equal to 0, the x squared term would vanish and the degree of the equation would become 1. So it would no longer be a quadratic equation. So now that you know the definition of a quadratic equation and what its standard form is, let's do a quick recap of what we learned today. We looked at some real-life problems where we need to apply quadratic equations. We defined a quadratic equation as an equation in one variable and a degree of 2. And finally, we learned that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a, b and c belong to real numbers and a is not equal to 0. Awesome! But we still haven't solved our puzzle. All we know for sure now is that this equation is a quadratic equation, but we still don't know the ages of Jay and Viru. To know how to solve this puzzle and similar problems using quadratic equations, go check out more videos on this topic. I'll see you soon.